In this video, we're going to look at exactly what an angle is. We're going to look at the units used to measure angles, and we're actually going to even measure some angles together. So let's start off by looking at how an angle can be created. So I'm going to draw a ray with endpoint O, and then I'm going to draw another ray, same endpoint O. So an angle is created by two rays with the same endpoint. So here we have endpoint O and we have two rays and it creates an angle. Alright, so what is the angle part of this whole drawing? Well, the angle is the rotation between the two rays. So from here to here. And I'll get more into what I mean by the rotation between the two rays in just a moment. Alright, what else do we know here? Well, our rays are called sides. So we have the sides of our angles here. Actually, each one is just one side. So we have the two sides of our angles that create an angle. And we have the endpoint that those rays have in common is called the vertex of our angle. Alright, so now that we know what our sides are, what our vertex is, and where our angle is, let's now look at how to name the angle, and then we'll move on to the fun task of measuring the angle soon. Alright, so how do we name this angle? Well, we can name it in multiple ways. As it currently is, we only see one letter. Let's say we had other points on those rays. So let's say this is A on that side and that's B on that side. We could name the angle, we could give it a number name. So I could say this is angle 1, or I could name it by the vertex. So I could say this is angle O. There are more options. I could name it with all three letters, just making sure that the vertex is in the middle. So I could name it angle AOB or angle BOA. So we have 4 options for naming this angle. So just so I am clear, here we can only use this option if it is absolutely clear that angle O is a specific angle. So if I had another ray shooting off this point, and let's say that we're C, well, I could no longer call this angle O because you wouldn't know if angle O is up here or down here. So when you're naming angles, it's important to be careful of that one little thing. Other than that, many options. Okay, but how are angles measured? All right. So how are angles measured? Well, first of all, angles are measured using a unit called degrees. And I would like to make sure you understand what a degree is. A degree is 1 out of 360 of the rotation of a circle. So let's write that down, 1 out of 360 of the rotation of a circle. What do I mean by that? Let's see. So here we have a circle. My best attempt at a circle. All right. And if I took my circle, I could chop it up into literally, well, I'm going big because it would be really hard to chop it up into 360 pieces, but this is my attempt at chopping it up into 360 pieces. Each one, so imagine that there were 360 little pieces here. Each one of those pieces represent 1 degree. All right, so there are 360 degrees in a full rotation. So there are 360 degrees, and that's the degree symbol here, in a full rotation. So I can use that information and start measuring angles. So let's use the pen here. From here to here, that is 1/4 of a full rotation. So that's actually 90 degrees. And we can keep going on and on and on with that. But here's the fun part. We have a tool used for measuring angles, and conveniently it's going to be either a circle or half a circle. So this tool here is called a protractor, and a protractor is taking that shape so you can figure out what portion of the circle you're dealing with. So notice on my protractor, I start off with 0 on the inside and I count all the way up to the first 90 and then going all the way down to 180. Or I could go on the outside and that would then be my endpoint. So I can start at 0 and then go all the way to 180. So the way it works is you choose whichever, the inside or the outside, that works better for you. So let's actually give this a try on the next page. Okay, so now we're going to get some practice estimating angle measure and then actually measuring our angles with a protractor. So the first thing I always think of whenever I'm estimating any angle is the fact that the 90-degree angle looks like this. And then I think of things in increments of 90 degrees. And you'll see what I mean in just a moment. So here I have two rays and they create an angle here. And now, as we can see, that is smaller than our 90-degree angle. However, it looks, is it closer to 90? Well, that's the halfway point here. Is it closer to 90 or is it closer to 0? Well, in my opinion, it looks a little bit closer to 0 than to 90. But now we can measure it and see. So let's go ahead and take our protractor. Now, a protractor, we want the center on the vertex of the protractor, and we also want, oh, look at that, I'm turning the angle instead of the protractor. Normally it would be the other way around. But we also want that 0, oops, there we go. So we want two things to happen. We want our protractor center to line up with the vertex of the angle, and we want our 0 to line up with the side of the angle. Once you have those two things accomplished, now we can see that the angle, if you look here, is at 25 degrees approximately. So we've just measured our first angle together, 25 degrees. All right, let's try one more and then we'll wrap this up. So let's make our angle a little bit bigger this time. My lines are terrible, but you get the point. So my vertex is right here, and I'm going to measure that angle. But before I do, I want to estimate. So recall that that is 90 degrees. Is this bigger or smaller than 90? Well, it's definitely bigger. But is it closer to 90 than it is to the next increment of 90? So we're counting by 90, 180. So is it closer to 90 or is it closer to 180? Well, to me, it looks a little bit closer to 90. But I'll let you measure and see. Or we'll measure together and see. Oh, I'm moving the triangle instead of the protractor again. Let's get that protractor. There we go. Alright, so we line up our protractor. And we have a little issue here. We need that line in line with our 0 degree mark. Or there is another option. So instead of trying to rotate my protractor or rotate my angle, I can keep in mind that it starts at 2 degrees. And hopefully you see that's 0. Let's see, let's point here. That's 0. That's a little bit more than 0. You can tell how much more. It's actually 1.5 degrees. But I'll round up to 2 degrees. So we start at 2 degrees. And we are using the inside scale because we're starting at 0. Using the inside scale, we end at 134. As you can see, we're approximately at 134. All right, so we go from 2 degrees to 134 degrees, which means that we can just subtract. And we get that the angle is actually 132 degrees. All right, how was your estimation skills? Mine was okay.